We have got Hakan Barak Karli of the College of Engineering.
Hello everyone, I'm Hakan Barak from Electrical and Computer Engineering, and I will be talking about my project. So basically, we are here to revolutionize neonatal care, ensuring every individual from their first breath receives equitable healthcare. The challenge we face isn't just confined to newborns, it affects people across all ages. Since 1976, the percentage of deaths due to respiratory health has increased only 3%. Doesn't seem much, right? But this seemingly small increase translates to 150,000 lives. It's times 273% in rise in mortality, a number that cannot and should not be overlooked. A significant contributor to these deaths is tied to a device that we have trusted for decades, the pulse oximeter. Designed to measure oxygen level hemoglobin, this tool unfortunately harbors racial bias. The pulse oximeter were designed considering how skin color can affect light absorption. Light goes through the finger during the process and goes out on the other way. So for darker skins, this means getting inaccurate readings, unfortunately. And this isn't just a technical problem, it's a matter of life and death. So my connection to this problem began while choosing becoming a doctor or an engineer. So during one of the visits to my father's clinic, I met Nazlı, a young girl with joy for life who later became a victim of the issue that we are discussing today. So after a routine operation, Nazlı's condition got worsened. Unfortunately, pulse oximeter biased against her darker skin provided wrong readings, and unfortunately, Nazlı didn't make it. So driven by the tragedy of Nazlı's loss, my career path was clear. To create a world where every newborn has access to fair and accurate healthcare monitoring by joining my team. So this was my turning point. Our mission is simple, yet clear. To create a world where every newborn has access to fair and accurate health monitoring. By introducing a new device, we are setting new standards for healthcare technology to ensure every child can access fair healthcare. So, in hospitals, we rely on three methods to measure oxygen: ABG, which can be painful due to puncture; pulse oximetry, known for inaccuracies; and other commercial monitors, which are not continuous or not variable. If we look at the timeline of oxygen monitoring, we see a lot, right? But now let's not talk about the past, all right, for a second. Let's talk about the future. I want you to meet with more our device. So our device basically has a groundbreaking approach with using optical science, optical values, optical technology. So with this device, we can detect, basically this project is more just creating something new, something better. So it's about making life equal for everyone in this world. So you may wonder how this device works, right? More uses light to emit and detect from our sensor. And with this data, basically we get the signal back. So using this signal, we basically work better, faster, and more accurately. So with using, as we said, we capture the data through incoming light. And with using this data, we basically develop racial bias mitigation algorithm in order to reduce bias in pulse oximeter readings. So if you look at the project plan, we basically passed the first prototype and we are doing some human trials right now. With using that data, we are going to develop a second prototype, then we'll move forward to human pilot studies. So at MSU, we are trying to build a computational model in order to see how oxygen diffuses through the skin. And with the help of that data and with some machine learning and signal processing techniques, we are going to reduce bias in SpO2 pulse oximeter readings. So with Mo, we aim for greater things other than something just in the lab. We aim for equity in healthcare, lower costs, reduce hospital times, and much, much more with this device. As we stated, we started human trials right now, and from the graph, you can see that we can detect occlusion and hypoxia just fine, which basically means we have a potential here So I want to thank my team for their unrelenting support, WPI for the first prototype, UMass for the first trials, and NSF and NIH for funding. We are pushing UNITL care forward together.